is Andreas Sauter, and I'm a graduate research assistant here at Tennessee Tech. I'm also the lead researcher working on the TechBot, which is a mobile multitasking 3D printer. We're currently underway of getting a provisional U.S. patent for the TechBot. And now, let me show you and tell you about some of the key features that make the TechBot different from other conventional 3D printers. The TechBot is a mobile multitasking 3D printer designed, developed, and fabricated by faculty and students at Tennessee Tech University. A provisional U.S. patent has been applied for due to its unique feature of dispensing many different paste-like materials like concrete and solder in any X and Y direction, also making it different from other 3D printers currently on the market. The TechBot is mobile and does not use filament, powder, laser, or resin found in other additive manufacturing processes. Potentially being used in several manufacturing and construction facilities, the TechBot can make anything from circuit boards to concrete structures. And because it can dispense any paste-type material, including food, the TechBot has already been used to make cakes, pies, and desserts. Now let us enjoy some footage of the TechBot in action before we begin talking about the details. Now that you've seen what the TechBot can do, let's talk about some of the details. The printing platform incorporates 4 omnidirectional wheels at the corners that improve the print accuracy and are the source of the machine's unlimited X and Y axis movements, based on user-defined settings. These omnidirectional wheels are 60 millimeters in outside diameter and have a 5 millimeter hub, which is then driven by a 48mm NEMA 17 motor. Since the extrusion head is incorporated within the frame of the TechBot, it is possible for one Z-axis to print multiple materials using different extrusion methods, making TechBot a multitasking interface. Currently, the TechBot uses a syringe-based extruder that uses a 27:1 geared NEMA 17 stepper motor to pressurize a 150 milliliter syringe. The extrusion motion is guided by the help of 2 linear bearings, and the Z-axis movement of the syringe extruder is forced by a lead screw. The TechBot is designed similarly to a Cartesian 3D printer, with the major difference being its omnidirectional wheels in the mobile base, which frees it from workspace constraints found in other conventional 3D printers. The TechBot is controlled by a MKS Gen L V1 board, which is also similar to boards found in other Cartesian 3D printers. The board runs on Marlin code that has been written to support the current setup of the TechBot. All of these important components are part of the overall frame of the TechBot, which is made from 2020 aluminum extrusion. Continuing on to some other TechBot components that were also designed and manufactured in-house by Tennessee Tech students. First off, the entire cable management system was designed in SolidWorks and 3D printed in-house. The cable management includes a cable box and 2020 aluminum extrusion covers to guide all the wiring. Another component that is important for completing the overall look of the TechBot is the acrylic glass and the acrylic glass mounts. The TechBot logos for the acrylic glass were designed and cut out in-house to personalize the exterior of the TechBot. The handles were also designed and manufactured to make transportation and printing setup easier. One more important component that was designed in-house is the LCD mount to make controlling more ergonomic. TechBot is the key to large area printing with multiple materials. While the TechBot platform is available as a kit that must be assembled, it can be put together by consumers of many ages because of its simple components and uncomplicated assembly procedures, allowing it to remain priced under $500. This makes TechBot valuable and affordable for a large range of customers, including many families and small businesses. TechBot is funded through NSF Award 1601587, Additive Manufacturing Workforce Advancement Training Coalition and Hub, AM Watch. Research team members are Dr. Ismail Fadan, leader, Dr. Michael Allen, co-leader, Connor Welcome, MET Undergraduate Research Assistant, Andreas Sauter, ME Graduate Research Assistant, and Aslan Nazirov, ME Graduate Research Assistant. The technical support received by Ed Tuckett from the University of Louisville, from Amy Elliott at the Oak Ridge National Lab, from Tom Singer at Sinclair Community College, and from Mel Cossette from Edmonds Community College is greatly appreciated. Thank you for tuning in to this video about the TechBot and what makes the TechBot different from other conventional 3D printers. If you want to see this entire print being finished, just remain watching.